So today we'll be looking at families of curves. A family is a group whose members all share something in common. Okay, so in terms of people, your brothers, sisters, aunts, uncles, parents, cousins, grandparents, all share common ancestry. A similar principle applies for polynomial functions. When you have a family of functions, it's a set of functions that share the same characteristics. And in terms of polynomials, they are said to belong to the same family if they share the same roots. Okay, so if they share the same zeros or x-intercepts. In general, polynomial functions belonging to the same family will have different y-intercepts unless the y-intercept is the same as the x-intercept, meaning unless it passes through that origin. So the way that we represent a general family is by putting in an a value. Okay, so if you see an a value, that is the general equation for a family. So in our case, we have y equals a times x plus 2 times x minus 1 times x minus 3. Okay, and this represents the family of functions that have the roots of -2, 1, and 3. If we wanted to find a specific member of this family, we can just plug in a number for a. Okay, so down here you'll see we plugged in a 2 and we plugged in a -1.5. Both of those are members of the same family because they share those x-intercepts in common. Okay, and these are just two members, but there are actually infinitely many members because there are infinite options for the a value. And then there is a one little note down here. A cannot equal 0. Okay, but it can be any other real number. So looking at what members of the same family actually look like on a graph, here I've graphed 3 of them. The blue one has an a value of 0.6, the green one has an a value of 1, and the purple one has an a value of 0.4. So we can see that they do share the same x-intercepts, which means they are the same family. And the a value is really just affecting the stretch and compression. Okay, so it's affecting how high the maxes are and how low the mins are. And you'll notice that they, of course, also, because they're stretched, they do have different y-intercepts. But they all share those same x-intercepts. So we'll go through some examples. The first question is asking us to determine a possible equation for a function with the following characteristics. Okay, so it's saying a possible function, so it's not going to give us enough information to solve for a very specific function. You can just choose any a value that you want. So for question A here, it's a degree 3 function. It starts in the 3rd quadrant and ends in the 1st quadrant. Okay, so if we were to draw that out, quadrant 1, 2, 3, and 4. So it starts in quadrant 3, ends in quadrant 1. Okay, and it's good that it has opposite end behaviors because it is degree 3, so we would have expected that. And if it's going from quadrant 3 to quadrant 1, what that really means is that our a value is going to be positive. Because we need to have a positive leading coefficient in order to have these end behaviors. Okay, they tell us that there are roots at -1 and 2. Okay, so those are going to be 2 brackets, and the y-intercept is the origin. Okay, so that gives us our 3rd x-intercept as well. So if we write this out, I'll start with the general form where I just put in an a value. We have the root at x equals -1, so that would be x plus 1 is the factor. We have a root at x equals 2, so x minus 2 would be a factor. And then because we have a y-intercept of 0, 0, that means that x is also a factor. And then it's asking us for a possible equation, so you can choose any positive a value you want. let's say 427. And then my 3 brackets stay the same. Okay, so there's a possible equation, but you could have chosen any positive a value that you wanted, and that would have been a possible member of this family. Next we have a degree 4. It says it falls to the left and to the right. So if we were to draw out those end behaviors, that would look like that, falling to the left, falling to the right. And when we have an even degree that is pointing down, that means that a is negative. And it tells us that we have double roots at both 3 and 5. So double roots means bounces. It's going to have a multiplicity of 2. For both of those. Okay, so if I write out my general equation here, I have a root at 3, and it has a multiplicity of 2, so I'm going to square it. And I have a root at 5, and that also has a multiplicity of 2, so I'm going to square it. And then we just need to choose an a value that's negative. So any negative number, let's say 1.5, and then my brackets, my x-intercepts don't change. Okay. And at the end, it's always a good idea to check to make sure that you fit all the criteria. It is a quartic function, right? 2 squareds would be a degree 4. So we've got that, has that negative leading coefficient, which causes it to fall, and it does have the double roots. So that is one of our possible equations. Okay, so our next example here, determine the exact equation. So for this one, you're going to have to actually solve for the proper a value. They're going to give us enough information for that. They say that it is a quartic function, so that's going to be a degree 4, with a root of x minus 4 and a point of inflection at x equals -1. Okay, so point of inflection, that's that wave. That means it has a multiplicity of 3. Okay. And then there is an y-intercept of 8, which really means that the point 0, 8 is going to be on our graph. So I can start by drawing in the point 0, 8 here. There's not a scale on the y-axis, so I'll also put in a scale. So there's my y-intercept. It tells us there is a root at -4, and there is a root at -1. It's quartic, so it's going to have to end in the same direction. And because it has to pass through these 2 x-intercepts and end up at the 8, I know it's actually going to start upwards, because that's the only way that we can pass through the 8. There's going to be a wave at the -1, and then it's going to go through that last x-intercept. So that's the only possible way to draw it. If you tried to start from the bottom, then you wouldn't have been able to get up to that y-intercept. So we know what it looks like. Now we just need to come up with an equation. So starting with the brackets that we know, the root at -4 means that x plus 4 is a factor. And the root at -1 means x plus 1 is a factor. And I'm going to cube it because it has a multiplicity of 3. The last step here is going to be to solve for the a value. So because we know a point on our graph, they actually gave us an x and a y value. So we're going to sub that in for x and y, and that will allow us to solve for a. So I'm putting in my 8 for y, 2 for x, 2 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 for y and I'm putting in my 0 for x. And here we would have 4 times 1, which is really just 4. So we have 4a, and then we divide both sides by 4 to get that our a value is 2. Okay, so that means that our equation is y equals 2 times x plus 4 times x plus 1 all cubed. And that is the exact equation that fits these criteria. And there's only one possible answer for that equation. Okay, you might have written the brackets in a slightly different order, but it's still the exact same equation. So here is our last examples for today. So find an equation for a family of cubic functions whose x-intercepts are -1, 2, and 5. This time they're not asking for a possible equation or the exact equation. They're asking us for the family. So if they're asking us for the family, that means leave the a value. So a family with these x-intercepts is going to have a general a value, and then each x-intercept is going to cause a bracket. So a factor of x plus 1, a factor of x minus 2, and a factor of x minus 5 would give us those roots. And there is our general equation for that family. Part B is asking us to find the equation of the member of this family whose graph passes through this point. So now we're finding a specific member, so that means solve for a. And they gave us a point, so they gave us the x and y, so we can sub that in to the equation that we have from part A. So I'm going to plug in -12 for y, and I plug in my 1 for x. So I have a 2, a -1, and a -4. That would give me 8a. And when I divide both sides by 8, I get -12 over 8, which is -3 over 2. So the equation for this is y equals -3 over 2, x plus 1, x minus 2, x minus 5. Okay, and that is that specific member of that family. Okay. So that is the end of the lesson, so you guys can begin working on the homework.